The product property of logs tells us that if we have a log of two things that are multiplied together, then we can break it apart with a plus sign. So there are two different things you're going to be asked to do on your assignment for tonight. One of them is to expand, and the other is to simplify. There are instances where it is helpful to expand, although I will say they usually show up in upper level math. Like in calculus, there's logarithmic differentiation that you can use that it helps to expand it. We won't see the applications of expanding so much in this class. It also sometimes can help you to simplify, because if you simplify, we will see the application of that, because if you simplify things, it helps you to solve equations. You can condense them so that you can solve the equation, and we will use that to some when we're solving equations. So, if we're asked to expand here, this would be, let me make this full screen. This would be log, ooh, switch colors on me, log base 3 of 4 plus log base 3 of x. I need to switch these notes up. Well, it doesn't matter. My smart board program is also, does crazy glitchy things like this, but it does not switch over easily to any other platform, so I can just keep using it. Alright, so if we look at number 2, our goal here is not to expand, but to simplify, so we're putting these together. First of all, they must have the same base to put them together. If they do not have the same base, you just have to leave it. It cannot be simplified.
Can we just drop the log?
You cannot drop the log, because dropping the log is for equations, where you have two sides of an equation, and you can drop the logs. These don't have equal signs with them. So if there was an equal sign instead of that plus sign, yes. But these do not have equal signs. So you have to combine. So you'll have log base 7 of 9 times 8. I'm writing this every single step just because I do that in notes to make sure everybody's following me. You can skip straight to this log base 7 of 63. No, 72. Gosh. Sorry.
I was going to go with that.
Yeah.
I was going to go with that. I had no idea what it was. I was like, all right. Yep.
That one's not even a bad one.
What is 63?
You can use your finger trick.
7 times 9 is 63, right?
Yeah. Yeah.
Okay.
Good job.
I'm just making sure.
Okay.
No. Not Miss Walker.
Hunter had Miss Walker too.
Really? She's pretty cool.
Yeah, he liked her. Alright. Okay. We also have what we call quotient property. It tells us that if we have two terms that are divided, we can break them apart using subtraction. So, if we look at example 3, it asks us to expand. So we could do natural log of 4x minus natural log of 7. Now, is this expanded completely? Is there anything else I could break up? What else could I break up, Luke?
The 4, yeah.
The 4 and the x are multiplied, so what would I put between them if I break those apart? Addition. So I would say natural log of 4 plus natural log of x. I'm going to put me some parentheses around that because that should be done first. Minus natural log of 7. Now, due to the general nature of order of operations, the parentheses there are optional because you would, if they weren't there, you would still do the first two first. But sometimes they are necessary depending on what order you have things in. So I just go ahead and play it safe and put parentheses around that. Okay? Questions here? To simplify, for this one, we would do log of 9 divided by 3, which would be log of 3. There. Again, you don't have to write that step. I'm just trying to be extra clear in notes so everybody knows what we're doing. Okay, questions? All right, power property. If you have a term raised to a power here, you can take that power and pull it out front as a coefficient. So if I have log base b of m to the p power, I could write it as p times log base b of m. So if I look at example 5, I have this power right here. I could pull it out front as a coefficient. So that would be 3 log base 3 of 4x. I could expand that further because I've got the 4 times x there. It is necessary for you to have parentheses here because if I just write 3 log base 3 of 4 plus log base 3 of x, if I write it like this, then the 3 is only multiplied by that first term, not by the second. So you do need parentheses here. They are required. Here you're incorrect. So I would just be in the habit, as you break things down further, put parentheses around the next step that you have done there. Okay? Questions so far? All right, for example 6, we're asked to simplify. So the first thing, we do have a plus sign here, but notice that we got this 2 right here out front and this 3 out here right here out front. We cannot combine those until they're just straight logs, right? So this 2 and this 3, they have to be pulled in as exponents first. So we'll have log base 2 of x squared plus log base 2 of 4 to the 3rd power. Okay, that is going to be 64. I'm going to write that. And then if I have addition, how do I combine that whenever I put this all together? Multiplication. So I would say log base 2 of, you could do x squared times 64, but that's not very standard notation. Normally we would put the coefficient first, so we'd normally write this 64 x squared. Okay, questions? All right, equality property, we actually already did this yesterday. The equality property tells me if I've got log base b of m equals log base b of n, then m must equal n. What would Coach Wood call this? Dropping the logs, right? So this is your drop the logs property. Now, let's look at the example I've given you. Can the logs be dropped?
No, there's only 2.
Not yet, because you've got this 2 on the outside. So that 2 has to be brought in as an exponent first. So we would have log base 3 of 4x equals log base 3 of x plus 1 squared. Now, logs can be dropped. So I've got 4x equals x plus 1 squared. Oh, let's test your algebra skills here.
That's 2x plus x squared. Okay.
We can't do anything while we got the square over here on the right side.
Well, that's why you put 2. You could just put like that and then multiply it by the same thing.
Okay, so you're saying when you say that, you mean
Like x plus 1
X plus
times
1.
x plus 1.
Right, when we have x plus 1 times x plus 1, x plus 1 squared, this is what it means, right?
X
I heard somebody say take the square root of both sides. That will get rid of our square. Here's the problem. If you do that, you got square root of 4x equals x plus 1. And now that x is trapped under a square root, which is not good. The only way to get rid of the square root is to square both sides, which just gets you back to where you were at before. So although it is a possibility, it's not going to get you anywhere. So if we do this, x times x is x squared. X times 1 is x. We got x here, and we got 1. So we got x squared plus 2x plus 1. Now, I, at this point, really want you, if possible, to do that in your head. Now, I teach students whenever, so if I were doing this problem, I teach students when you're squaring a binomial, that's called a binomial when you have that x plus 1. I teach students to square, double, square. So you're going to square the first term, so that'll be x squared. Then you're going to multiply both terms together and double it. So 1 times x is 1x. Double it means to multiply by 2. That gives you 2x. And then you square the last term. So square, double, square. Square. Have you guys been told to square, double, square before? There may be some of you that did do that in your head, but just haven't heard it used called that. I mean, that's not some sort of mathematical term or anything. That's just what I call it to help us remember. But we'll work on that as well, because in order to be efficient, we would like to not have to write this over to the side, because it makes the problem much longer. It's more room for error. So if we can square, double, square whenever we get these, it's going to save us some time and make us more efficient solving problems. All right. What next?
Subtract 2x.
I can. Then what am I going to do with that x squared, though? If I do, don't write this down. I'm going to do it, but don't write it down. I feel like a dead end's coming on. If I do this, I could square root, but then I end up with an x trapped under a square root again. So it's legal to do those things, but it's just not getting us anywhere. This is a quadratic because it's got that x squared. Anybody remember how to solve a quadratic? Factoring is one way we can do it. All over 2a, yes. So quadratic formula, factoring, or we can complete the square is another possibility. So in order to do any of those, though, I have to have everything on one side. It has to be equal to 0. So we're going to subtract the 4x. And we'll have 0 equals x squared minus 2x plus 1. And so if, especially when you have small numbers like this, if it will factor, factoring is going to be quicker. So if I factor here, I've got an x here and an x here. I need a minus 1 and a minus 1. And then that will work. If I multiply it back, I'll get what I started with. And then I need to set each one of those equal to 0 since they're the same. I can just do it once. So I add the 1, x equals 1. So finally, we have an answer there. Okay, so that problem brings in, sometimes you'll see these, it brings in some of the algebra from long before we've gotten here. So we'll practice more and more with that. Questions on that one? Okay, so your homework tonight is going to be from Delta Math, and the problems are going to look like what we see here. So it's going to say either condense or to write this as a single logarithm. Both of these mean to condense. This is the wording Delta Math is going to use. So if we're asked to condense one like number 8, we need to pull in anything out front as exponents. Some students don't like it when they do this. They've got letters instead of numbers here, but that just represents a number. So we could write this as log of b to the 8th minus log of d to the q. That gets rid of our coefficients that we had. Now we have subtraction. What do we have to use for subtraction when we combine? Division. So we would have log of b to the 8th over d to the q. And that is what you would type into Delta Math. It lets you type in equations there. It'll have little tools for fractions and stuff. If what I need to do, you can still do this, but what I will need to do is I will need to send you guys the join codes for Delta Math. So Delta Math is separate from Canvas, but I will, at the end of class, I will send you guys the join codes so that you can join Delta Math. Because if otherwise, that is on Canvas. Hold on, we're going to do a couple more problems. We've still got 5 minutes. We might not get them all, but we're going to do a couple more. And I will send those to you. So we're going to skip this one. When it says write the expression below as a single logarithm, only thing you're doing on that one is pulling that in as an exponent and writing that one out. I'm going to skip over that one so we can do one where it's expanding. This is asking you to expand, and if you expand, you have to expand completely. So let's do 11 because it's a little bit bigger than 10. So if I were expanding this, the first thing I would do would be to break apart that fraction. So that would be log of x cubed y squared minus log of z to the 4th.
Would you like to bring the 4 out? For the log,
you cannot take the exponents out before you break that stuff up unless that exponent applies to all of the terms, right? So if you had something like this, log of x over y to the 5th power, like that, you could pull that out first, like that. But because these all have different exponents, you can't pull those exponents out yet. Here, same thing. We can't pull exponents out yet for this because these two exponents are not the same. So we would break that up into log x to the 3rd plus log y squared. You can put parentheses here if you would like. Because of order of operations, it's not required. But I think it'll take it either way. And then last on this one, you would pull the exponents out. So you'd have 3 log of x plus 2 log of y minus 4 log of z. And you can put parentheses around this or not because of order of operations. It's not necessary for that, but if you put it, it won't hurt. Okay, questions? All right, here's the last one that it's going to ask you to do. All right, this does not tell you that A equals 5. It tells you log A equals 5. So what you've got to do on these questions is you've got to break them apart first and then replace. So it will look like this. Log of the square root of B cubed minus log of A to the 7th, C to the 7th. Now, that square root stuff, we really should have done that as warm up. This is the square root of B to the 3rd. Square root of B to the 3rd can be written as B to the 3/2 power. So if you have a root, you're going to have to write it as a fractional exponent there. So we could write that as log of b to the 3/2 power. And then we need some parentheses here. We'll have log a to the 7th minus log c to the 7th. I'm sorry, not minus, plus. And last, all your exponents can come out. So you'll have 3/2 log b minus 7 log a plus 7 log c. Okay.
You would like this 7 times 11. And then like
So now we'll have 3/2 times -4 minus 7 times 5 plus 7 times -11. And you'll figure out what that is, and it's time for you guys to go, so I'm not going to do it, but you'll just figure that out, and you'll type in a number answer for that. Okay, so this is on Delta Math. Those of you that are in Canvas, go to Canvas. There's instructions there on how to join my class for Delta Math, and use the join code. Those of you that aren't in Canvas, I will send you guys an email. Quiz is going to move because we didn't get through that one last thing that I wanted to do. So I will let you guys know tomorrow. Because I